Hey, welcome to this new lecture of Arduino. In this lecture, we are going to talk about serial monitor. As you can see here, we have serial monitor. We can get some data from Arduino and see it in our computers. It is very useful when we want to debug our code. Sometimes when we compile our code, it doesn't show any error, but when we see the circuit, it doesn't work the way we want it to work. So there are some logic errors in our maybe circuitry or maybe code. With serial monitor, we can see this. Also, another use of serial monitor is when teaching this Arduino, for instance, loops and stuff. It is very easy to use serial monitor instead of making a circuit for every topic. So we have a function for a method for beginning the serial monitor. We just write in the void setup, we just want to begin this serial monitor, start this serial monitor just for once, and we have to write serial dot begin, and in the parentheses we should write the baud rate. Baud rate means how much data in 1 second, I guess. So our baud rate will be 9600, and I will close the parentheses and semicolon. It started the serial communication. Now in the void loop we can print stuff on the serial monitor. So for this also we have a function, a method. Just write serial dot print, and then for instance let's write hello world. For strings you have to put this, whatever these are. Okay, I forgot just their name, but you have to put this, and you can write anything. For instance, let's write hello world. Okay, let's send this on our Arduino and see. Oh, I forgot the semicolon. I did it on purpose. Okay, now it is uploading. Done uploading. Let's see what will happen here. Okay, it just writes hello world again and again because we wrote this in the void loop, so it just writes all the time. So but we cannot see them properly, so let's put a delay here, and let's make it 100 milliseconds. 100, is it correct? I don't know, 100 or 100. Someone write me on the comments. So let's upload this one and see what happens. So now, as you can see, it just writes hello world again and again, with slower this time. Let's put a space here so that we can separate them. And let's also make this 1 second. Okay, let's upload this one. Now it is uploaded. See, it just writes hello world again and again. There's we could make this line by line instead of writing beside this every hello world. We can make it line by line, and by just typing ln here, print ln. It is like in lots of languages it is the same thing, just ln. Okay, let's upload this one. Okay, let's see. So as you can see, hello world is written in every line, and it will continue doing this forever until the chip is broken. Yeah. Now, of course, our purpose of using serial monitor is not just writing hello world. For instance, we have a function, or we have an if statement. I didn't show this if as statements yet, but we have a condition here, and then we want to check if this our code comes to here, or our circuit, our Arduino comes to here. Beside our code, for instance, do something. Here we just write something, some code, and then we just print serial print Arduino was here, for instance. So it executed this code, and you can see that Arduino came here. Let's make this comment. You can see that Arduino came here, so that you can debug correct your logical errors, that do not show in the compiling, verifying, but you can see from your serial monitor that there was an error. For instance, we can use integers or all kind of data types here. Let's make an integer. Let's call it x, and let's initialize it with 0. Oh, sorry, 0. And if I wanted to serial print x, I will just write x, because when you write variables, you don't put these things. I forgot their name. Anyway, you just write the variable. And now if I wanted to see this, it will write just the value of x. See, it just writes 0, 0, 0 all the time. Let's make x, let's add 1 to x every time it executes this loop. Okay, so how are we gonna make this? There are two ways. We can just types x plus plus and semicolon. It makes x 1 higher. I mean, it adds 1 to x every time this loop is executed. Let's see how it works. 0, 1, 2, 3, and it will go like that. Also, we could make x equals x plus 1. As I said, this equal sign is not the equal sign in math. It is different than that. It makes this x, whatever the left hand side, makes equal to this right hand side. So it was like 0 at the beginning. So it was 0, 0 plus 1 equals 1, and it makes this x's new value 0 plus 1. So it becomes 1. Then in the second loop, x was 1. So 1 plus 1 becomes 2 here, and the new value of x becomes 2. So it works like that. Let's see also this one. It will do the same thing. Okay, it does the same thing, as you can see. Let's multiply x every time by 3. But we cannot initiate it 0, because if we multiply 0 every time with 3, it will be 0. Just let's make this 1 for the first time. Let's upload this one. And 1, 3, 9, 27, and it goes like this. So this became minus after some time because it overflowed integers space. The integers the maximum number that can an integer get. So when it exceeds that maximum number, it just becomes -1, and then it goes in minus, and when minus is finished, it goes to plus again, plus sign, negative and positive. So that was it for this lesson. See you in the next lecture.